Hello! In this video example I'm going to be doing a stoichiometric calculation. It's called mass to mass, meaning I'm going to be starting with grams and I'm going to be converting to grams. Remember, for every stoichiometric calculation you can use your 5 steps. If you follow these 5 steps every single time, it will guide you to the correct answer every single time. Alright, and in order to do this, this is very math oriented, I'm going to need a calculator. And a calculator is pretty much something that you should bring to class every single day if you're a chemistry student. Okay, so first step, write and balance the equation. We got 2 KClO3 reacts to form or decomposes to form 2 KCl plus 3 O2. So it looks like it's already balanced, so we don't have to worry about that. We move right on to step 2. It says write down given information. So given information says how many grams of potassium chloride are produced if 25 grams of potassium chloride decompose. Our given information that really matters is pretty much the only number that they give you in the problem, which is 25 grams. So I'm going to write down 25 grams of potassium chloride, which is KClO3. Alright, that's step 2. Now I'll go right on to step 3, which is convert given into moles. I'm going to do a little mole conversion. I put moles of KClO3 on top and the molar mass, grams of KClO3, on the bottom. So for every 1 mole I have this many grams. Now in order to find the amount of grams in 1 mole of a substance, I'm going to have to use my periodic table. So I'm quickly looking up where is my periodic table. Looks like it's right there. Apologize, I don't have this up right away. Well, if I look at the periodic table, potassium is 39.1. Who needs a periodic table when you got all the atomic masses memorized? And chlorine is 35.5 and oxygen is 16. And we multiply it by 3. That's the wrong one, we'll forget about that. Alright, so we add these up. That's where our calculator comes in handy. 39.1 plus 35.5 plus 16 plus 16 plus 16. Alright, 122.6. 25 times 1 divided by 122.6 gives us our moles of KClO3. Plug that in the calculator. 25 divided by 122.6 gives me 0.20. Moles of KClO3. I'm going to rewrite that down here so that we can do more stuff with it. Why am I putting that 0 after the 2? Because that 0 shows significance. I have 2 significant figures, so I need to have 2 here. Although, if you have a nice graphing calculator, I wouldn't round it. I would just keep on doing your calculations until you have your final answer, and then round your final answer based off of the number of sig figs you started with. Alright, 0.2 moles of KClO3. We just finished step 3, convert to moles. So we move on to step 4, which is really the only thing new to stoichiometry. It's a mole-mole ratio. Use a mole-mole ratio to convert between different substances. We are getting rid of KClO3, and we want to convert to how many grams of potassium chloride? That's KCl. Alright, where do we get our numbers in our mole-mole ratio? We get them from our coefficients found in our balanced equation. So we've got 2 moles of KCl over 2 moles of KClO3, which really doesn't change our number. The only thing it changes is our unit. We have 0.2 moles of KCl. That might be our final answer, but we got to do step 5 just to double check. So let's convert moles of new substance into requested ending units. And the problem is saying how many grams of potassium chloride we have moles. So the last step, convert to grams. Atomic mass of potassium, 39.1, chlorine, 35.5. We add those 2 guys up. 39.1 plus 35.5 gives us 74.6. Alright, now all you got to do, moles cancels out. Take 0.2 times 74.6 times 5.2 That gives us 14.92. 14.92 grams of KCl, but we got to make sure we're correctly rounded according to correct sig figs. 25 has 2 sig figs. This has 4. We need to round this to 2 sig figs. So that's going to round up to 15 grams of KCl. And that is our final answer. And that is how you do a mass-to-mass stoichiometric calculation.